Welcome to Brain Vision.
So once again, just to get an understanding of this new problem, we have a block of ice that sits on an incline, and the mass happens to be 2.00 kilograms, and it slides a distance 1.35 meters down the block or down the incline at an angle theta equals to 36.9 degrees, and then the initial velocity happens to be 0 meters per second because the block starts from rest. So the block is sliding from rest, so the initial velocity happens to be 0 meters per second. The other thing that happens is the weight is mg. Components of the weight are mg cosine theta, and the horizontal component is mg sine theta. The horizontal component is responsible for sliding the block downwards. So if we use Newton's second law of motion, we know that F equals to ma, and this F is this horizontal force that's responsible for sliding the block all the way down. So then mg sine theta equals to ma. The reason why we're doing this is we can get an easier formula for the acceleration down the incline. So A equals to g sine theta. Our goal is to find the final velocity at the bottom of the block. So using the equations of motion, v final squared equals to v initial squared plus 2as. But remember, v initial was 0 meters per second, so we have v final equals to the square root of 2as. A happens to be g sine of theta, so this is radical 2 g sine of theta times the displacement down the incline, which is s. So this is 2 times 9.8 meters per second squared times sine of 36.9 degrees, and then times the displacement s, which happens to be 1.35 meters. And this gives us final velocity of 3.99 meters per second. I hope you enjoyed the video. It was a connection between Newton's second law and the equations of motion. And also, in addition to that, we're able to resolve the weight into two components. The horizontal component is responsible for moving the block down the incline up until the ground level. The vertical component is balanced out by the normal force. Okay, so we don't see any action from the vertical component other than the fact that it keeps the block of ice on the incline. I hope this makes sense. You can reach out to me, send any questions my way, and I hope you enjoy the video. Okay, thanks, bye.